Hi, and welcome to another episode with me, your host, Arvid Fian. And I'm really excited about today's episode because today I'm doing my first solo episode and we are going to get to the core of what climate economics is all about by talking about the harm of climate change. Because climate change is happening. But while we often hear general statements like climate change will be harmful, to an economist, the question is how much? How harmful is climate change? What are the damages expressed in monetary terms? Because as a society, we have limited resources. And the money we spend on fighting climate change, we cannot spend on other things like better healthcare or education. So there is a trade-off to be made. So in this episode, I want to give you the tools to calculate the magnitude of climate damages yourself. And I'm going to do that by giving you some emission numbers and some estimates of climate damages. And then in the next episode, I will explain more about what is behind those climate damage estimates and why certain estimates are more credible than others. So let's start off with some essential climate statistics. First, do you have an idea of how many tons of CO₂ the average person emitted in 2023? Feel free to pause and make a guess. The answer is 4.7 tons of CO₂ per person. So that's our global average, this 4.7 tons, and our first key number. In addition, there were around 8 billion people in 2023. So if we multiply those two numbers, the 4.7 tons of CO₂ and 8 billion people, we get about 38 billion tons of CO₂ that were emitted in 1 year. So the 38 billion tons is our second key number, and we will use that later. Now, let's do the second part and move from quantities to damages. And the key concept economists think about is the following. How much economic damage results from emitting one additional ton of CO₂ into the atmosphere? That is what economists call the social cost of carbon. In other words, we emit 1 ton of CO₂ today, and that ton contributes to global warming, which creates damages from lost agricultural yields, increased mortality, lower labor productivity, and so on. So economists estimate those future costs, discount them back to today, and then sum them up. And that would be the social cost of carbon. One number today that captures the damages to everyone on the planet for all upcoming years. So to get a sense of the range of estimates, let's have a look at the United States. Because in the United States, governments are legally obliged to have some estimate of the social cost of carbon. And under the Obama administration, the social cost of carbon was estimated to be around $50 per ton of CO₂. Now, you can probably guess which direction it went under the first Trump administration. And if you predicted it would go down, you would be right. Because the social cost of carbon estimate decreased to around $2. Then President Biden got elected, and an agency estimated the social cost of carbon at around $185 per ton. And under the current Trump administration, it's currently been set to zero. So under Obama, it was $50. Under Trump, it's basically zero. And then under Biden, it became $185. So these estimates vary substantially. And in the next episode, I will show you why these different governments obtained such different numbers and why some estimates are much more credible than others. Meanwhile, let's also look at the European Union. In the European Union, there is no explicit social cost of carbon. However, the European Union has an emission trading scheme, and that means that companies have to buy permits to emit CO₂. So the European Union essentially adds a carbon tax to pollution. And while I will discuss this emission trading scheme in more details in 2 episodes from now, for now, I just want you to know that the prices of those emission permits have ranged from 80 to 100 euro per ton of CO₂ in recent years. And those numbers are between the numbers of the Obama and the numbers of the Biden administration. So remember, the goal of this episode is to give you the tools to calculate climate damages. And now we have some emission statistics and a range of numbers. And that is enough to start calculating damages. So let's run some numbers. Let's say, for simplicity, that each ton of CO2 causes €100 in damage. And let's approximate the global average by 5 tons per person. That then gives us €100 times 5 tons. That gives us a total damage of €500 per person per year. Now you can scale this up or down based on your estimate. If you think that the true estimate of climate change damages is lower, say €10 per ton, then the damages would become €50 per person. If you think the estimate from climate change is higher, say €200 per ton, then the damages per person become €1,000. Now those are the damages per person. But what about the damages on a global level? Well, we can do that too. Multiplying the number we saw earlier, 38 billion tons of CO2, by €100 per ton, that gives us an estimate of €3.8 trillion per year in damages. In addition, global gross domestic product, a measure of how much we produce, was €100 trillion in 2023. So we're talking about damages of 3.8 trillion divided by 100 trillion of roughly 3.8% of global GDP, all tied to climate impacts on current and future generations. Now again, this was an example of the calculation. You can then rescale the calculation based on your estimates of how harmful climate change is. For example, at €10 per ton of CO2, the additional damage would be €380 billion, or 0.4% of global GDP. At €200 per ton, the additional damage would be €7.6 trillion, or 7.6% of GDP. So once you have the social cost of carbon and some emission statistics, it is relatively straightforward to calculate climate damage. Now, this damage estimate is not simply a matter of belief, but should ideally come from a rigorous evaluation of the future damages. So make sure to catch the next episode where I tackle this in more detail. But the goal of this episode was to give you initial feel for damages through ranges. So we now have discussed the main calculation. However, I want to point out a few additional considerations. First, these damage estimates are averages, but climate change will hit some regions harder than others. For example, rising sea levels might impact some regions more than others. And if you want to learn more about that, I recommend my second episode with Harvard economist Ishan Nath, where we discuss why agriculture in the global south will be hit harder than the north. Second, we have not taken into account the additional damages arising from air pollution due to fossil fuel combustion. And that was a topic of my interview with Dr. Krista Hasenkopf in episode 3. A third consideration is we have only talked about CO2 emissions. However, there are also other greenhouse gases, like methane and nitrous oxide, which are much more powerful gram for gram than CO2. But they do disappear faster from the atmosphere. Now, scientists have constructed a method to convert these other greenhouse gases to CO2 equivalents. So if you do those calculations, then the average CO2 equivalent per person would rise from 4.7 to 6.7 tons CO2 equivalent per person. So that's about a 40% increase when we include those other greenhouse gases. However, the calculations we did earlier are a bit trickier because of the other properties of these gases. And I might cover this in more detail in a later episode. Now, a final consideration I want to discuss is regional differences in emissions, because we only talked about global averages so far. So let's start with the country that emitted the most in 2023, which is China. China emitted about 12 billion tons of CO2, or 32% of global emissions. But China also has 1.4 billion people. So that's about 8.5 tons per person, nearly double the global average. So next up is the United States. The United States emitted less, but still around 5 billion tons of CO2. And that is about 13% of global emissions. So China was 32, the US is 13% of global emissions. On the other hand, The United States only has 350 million people. So per person, the emissions in the United States are around 14.3 tons. Remember, our average is 4.7. US emissions are around 14.3 tons per person. So they're practically triple the global average and 6 tons more than China. Now, moving on to India and Europe. India emitted about 3 billion tons, whereas the European Union emitted about 2.5 billion tons. So in total emissions, they're about the same. But as you probably know, India has a lot more people because India had 1.4 billion people in 2023, whereas the European Union only had 450 million. So India's per person emissions are just 2.1 tons, so more than half the global average, while the European Union's average is around 5.6 tons. And then finally, we'll close out with Africa and South America, which are quite similar in terms of emissions. Because Africa emitted 1.4 billion tons and has an average of 1 ton CO2 per person, so a lot less than the global average. And then South America emitted 1 billion tons of CO2 and a slightly higher average of 2.6 tons per person, but still lower than the global average. Now, we've done a lot of these global differences, but now let's play with a thought experiment. What if India's per person emissions would rise from 2.1 tons to 8.5 tons, which is the level of China? So that would be an increase of 6.4 tons per person. Now multiplying that by 1.4 billion people, and you get an increase of about 9 billion tons of CO2. And that would make total global emissions go up from 38 billion to 47 billion tons, which is an increase of around 25%. So that's a big jump, and this calculation illustrates a very significant challenge that we face today. Because as developing countries grow, their emissions are likely to rise because they want higher living standards, like the rest of the world. So this tension, for example, is one of the central tensions that are going on in climate negotiations. Now, we've done some global averages, we've done regional differences. Let's zoom out for a second and let's think of all the emissions we put in the atmosphere. What do you think is the total amount of CO2 we have emitted since the Industrial Revolution started? The answer is about 1.8 trillion tons of CO2. Now, to make that tangible, that's about 225 tons per person. So the annual emissions were 4.7. In total in the atmosphere, we have 225. So about 50 times that. And so we're adding about 2% to total emissions per year. So let's stop here for today. In this episode, we did several things. First, we looked at how much we emit, which is 4.7 tons per person globally, and the differences between regions, which were substantial. Second, we introduced estimates of the damage of climate change. We then used several reference points to do some simple damage estimation calculations, with potential losses ranging between 0.4 and 8% of global GDP. Now, as I said before, in the next episode, we are going to go deeper into the economics behind the estimates of the climate damages and why the different United States administrations obtain such different numbers. So thank you so much for listening. And if you enjoyed this episode, I'd really appreciate it if you could leave a rating or otherwise share with someone who might be curious about this. So thanks for joining in, and I hope to see you in the next episode.